Alright. Who would like to walk me through what they did?
I first started off by making the fifth root into a fraction exponent. I made the quantity of 3 minus 2b to the 1/5 power.
Alright, so you change that to the 1/5.
And then using some of the rules, I made it to 3b minus 2b to over b to 1 plus 1. No, I made it like
Did I do that wrong?
is that what I did? I did 3b minus 2b to the power of 1 plus 1 over 1 plus 1. That entire quantity to the 1/5 power is 1. I think I'll show you like that.
Yeah.
I don't know if you can read my chicken scratch bits.
Of course I can. So, alright, so you said 3b minus 2b to the 1 plus 1 power over 1 plus 1, and all that to the 1/5 plus 1.
All of that all over 1/5 plus 1.
Alright. Oh yeah, and plus c. Anybody agree with that? Anybody disagree with that? Um, I would vote for disagree, and no offense. But where might be an issue would be. All right, outside. I'll, I'll kind of sum up what I think I just heard. You kind of went inside and started attacking each individual thing when you can't really do that. If it's a quantity, like it's a quantity here, you can't just integrate the 3, integrate that, and then try to integrate the whole thing. So, a noble first attempt. I mean, this is your first attempt at doing this. So I would say that this one's probably not going to be the case, because you can't just go in here, go in here. I like this. This is good. This is what we want to think about. Alright, so 3 minus 2b to the 1/5 db would be 3 minus 2b No, you can't distribute that. Because this is all to the 6th, everything in here is to the 6/5 power. But we're close. Because you're dividing by 6/5, so you have to multiply by the reciprocal, 5/6. You're getting there. All right. We'll go over there. Um, necessarily that. But you're on the right track with the idea that there's a chain rule that happens somewhere. Well, we're getting there. So, Sean, you,
No, I was gonna say like you could change the a minus 2b.
all right. Now let's think back to f of x, or f prime of x, would be equal to this: 3 minus 2b to the 1/2 power. We've already kind of established that whatever's in here is going to be raised to the half power, or it's going to be, we're going to add 1 power to it, right? 1 degree to it. I just didn't want to deal with 1/5. So we know f of x is going to be equal to, that's to the 6/5 power, right? Now remember how we would take the original function and then just put a constant right in front of it? Well, we don't need that yet. And I would put an a there because there would be a number that would be multiplied by it. It would just happen to kind of disappear on us. Now, if I did this and I said, all right, and you guys recognized right off the bat that it's going to be this 3 minus 2b to the 1/5 power. And it's going to end up being this to the 6/5 over 6/5. I like that part. You guys saw that? It's like saying if it was x to the 1/5, it would end up being x to the 6/5 divided by 6/5. All right. But now when it's a little bit more than x, we have to go back and we have to take a look at, all right, what's going on in this case. Now, f prime of x in this case would be a times a times 6/5, right, times 3 minus 2b to the 1/5. This is what's in the integral, isn't it? But we're missing a constant of some kind because already there's crazy stuff going on here. Now, on the inside, if we took the derivative of it, there's a chain rule, isn't there? What would the chain rule of 3 minus 2b be? A -2. Because the derivative of 3 is 0. The derivative of -2b is -2. So if I multiplied this all out here, I would get -12a over 5. Sorry about all this craziness. Working with Sharpies is a complicated task sometimes. -12a over 5 to the 1/5. So that's our derivative. Alright, I want to give you guys a second to kind of have this sink in. The -2 times 6/5 would give you -12/5, right? But first off, when we took the derivative, did it make sense that we had 6/5 times 3 minus 2b to the 1/5? Because you just, power rule says you subtract 1, right? Which would be 5/5. So, n times something to the n minus 1. This was chain rule. So this guy was my chain rule. And I put an a in front of there because we have, remember we have these mysterious constants and coefficients that pop up? So when we're talking about this, a could be 1 and we could be just done with it. But I don't know if a is going to be 1. Now, This derivative that we got, negative 12a, because negative 2 times 6 is negative 12, and I just multiplied it by a, so I got negative 12a over 5, times 3 minus 2b to the 1/5 should be equal to what we had before, or what we got from the original derivative. What was the original derivative? Well, the original derivative is 3 minus 2b to the 1/5. So this was f of x. That should be equal to negative 12a over 5. Let me move that up here. Times 3 minus 2b to the 1/5. Yeah. Go ahead.
When you went from f of x to f prime of x, up top,
Here?
yeah, you went a times 6/5, okay, and then you went times 3 minus 2b to the 1/5. Wouldn't it be to the 11/5? Because if you add 1,
But we're taking a derivative.
yeah, I know you take.
What's the derivative of x squared?
Oh, you minus 1. I got you. I was confused about that.
All right, so now, what's the coefficient here? Out front. 1. What's the coefficient over here? Negative 12a over 5 should be equal to what? 1. So a should be equal to... You guys are so demanding. It's working perfect on my desk. This guy's kind of like my abstract function, because I put an a in there. Because we don't know what that a actually was to begin with in the original function. Because the original function, the derivative, the integral that we're taking here, it got rid of. When you see this, you say, oh, there was a chain rule that had to have happened, right? Because this isn't x. This isn't something that isn't normal. This is something that should have happened. There should have been a chain rule, which means there should have been some kind of number there somewhere, some type of coefficient, but there wasn't any. So I don't think, maybe not obvious, but in the original function, there must have been a number that would have undone whatever happened with the chain rule and with the power rule. So those two values that we got from the power rule and from the chain rule got undone somehow by some number that was there as a coefficient. So we're looking for this evil coefficient that undid everything that the derivative would have given us. And that's what this was. And in order to find the evil coefficient, here it is. That's the evil coefficient that screwed everything up. Well, it didn't screw everything up because it made a nice, easy integrand. But it took the derivative and it got rid of every coefficient that would come from either the chain rule or from the derivative itself. And what we got here is negative 5 over 12. So the original function would be negative 5/12 What was the power? My brain locked up there. Sorry. My brain is only my brain doesn't work anymore, and so it locks up frequently. It's like it's an older model. What can I say? Yeah, no math should be done before 10 o'clock. All right, now, then we ask ourselves, is this going to be enough to get rid of, like if I took its derivative, would I get back to, because remember, our original was this, 3 minus 2b to the 1/2 db. Geez, what is it with this? So, all right, 1/5. Now, if I took this derivative, am I going to get back to this? Let's check it. All right, so we're going to get negative 5/12 times what, 6/5 to the 3 minus 2b to the 6/5. And I don't know the constant, but that's just a 0. Yeah, like I said, 1/5. And then chain rule, right? Chain rule. What's my chain rule? -2. All right. Now, the 5's divide out, correct? 6 goes into there how many times? 2. -2 goes into how many? The -1/2. What happens when that happens? It's all gone. So f prime of x is equal to 3 minus 2b to the 1/5. Is that what we wanted? Oh my goodness, we made it. Now, let me ask you this now. Since I ran out of paper, even though I have a total blank spot right there. That's how calculus problems sometimes work. If I'm gonna jump right over to here. I'm gonna jump right over to here, and I got my a that was -5/12. Can you break this down into the two parts, the chain rule part, and what we had to do from the integral?
5/6 and -1/2.
5/6 times -1/2. So we ended up with we got some weird way of dealing with, all right, the chain rule part ended up being not necessarily, the chain rule part was a -2, but I ended up using -1/2. What is the relationship between the -2 and the -1/2? The reciprocal. So we ended up using the reciprocal of the chain rule. That's just what happened. When we ended up with our a value with that coefficient, the evil coefficient that made our integral work, we ended up with the chain rule being we ended up using the reciprocal part of the chain rule. Well, I don't know. And then this was just the integrand part. Once we integrated, we got that. It was part of the integrand part, but it ended up being, you know how we divided by 5 or 6/5, so we had to multiply by 5/6. That was the part of the integral. So this was a normal part. So this was normal because we divided by 6/5, which means we multiply by 5/6. But then we ended up having to use the reciprocal of the chain rule. So Sean's question is this always going to be like that? Well, let's make one up. 2 plus 4x to the 1/6 power dx. No, I don't want to make 1/2 in this case. Alright, so by our rule, I know we're going to get 2 plus 4x to the what power? Ah, got you on that one. Alright, but what about that coefficient that goes here? Alright, so we're not going to use 7/6, we're going to use 6/7, right? Because we would normally divide by 7/6. So we end up with 6/7 times. Now, what would be the chain rule from here? Positive 4. So where should the 4 go? It should become a 1/4. And so if I make this, alright, so let's see, 2 divides into 4 2 times, 2 divides into 6 how many times? 3. So it should be 3/7, 2 plus 4x. Sorry about that. Because I simplified. So I got 3/7. Now let's take the derivative of it. Yeah. I like 3/7 better. 3/14. I'm thinking about home improvement. 3/7 is easier. Alright, so let's go ahead. Let's take the derivative of this and see if we actually get back to what is inside the integral. Yes, ma'am. Because of this. What we saw from our first problem was we ended up here taking the chain rule, the value from the chain rule was a -2. We ended up using 1 over -2. So from this part, the chain rule would be a 4 so we use 1 over 4 instead. So let's see if it works. So the derivative of this would be 3 over 14 times what? So if this is f of x, f prime of x would be equal to 7 over 6, would you agree? Times 2 plus 4x to the 1/6. Now, what's the chain rule? 4. What's the derivative of the constant? Alright, plus 0. Now, does 13/4 times 7/6 times 4 equal 1? Well, 3 goes into 6 how many times? 2. 7 goes into 14 how many times? 2. So 2 times 2 is 4, but there's a 4 there. They cancel each other out. So that whole thing cancels each other out. We're left with f prime of x equal to 2 plus 4x to the 1/6. Isn't that what we wanted? Yes. Yeah, here's your answer. And then I checked it to make sure that I wanted to make sure that this was equal to what was being integrated. Here, let me do this. Ah! is so temperamental. So to kind of summarize it, and I ran out of sticky note. If you have like a plus bx to the nth power, use the power rule. But then we have to multiply it by 1 over the chain rule coefficient. Now, and notice what power x has. A plus bx. Can you guys not actually deduce things? Okay, just checking. Because if that's a plus bx, that should be a plus bx, right? Now, this is just a special case, but I wanted to do this problem mainly, one, because it's going to be on your homework, but two, because this idea of having to account for that chain rule is going to be more and more as we get into more and more type of functions. Now, if x was to a different power, that's a totally different case, and that gets into what we call U substitution with integrals, which is a little bit different. Because in the integral, you have to see a function and its derivative, and then we change things around a little bit. But with something like this, there's a nice pattern that pops up there. And we can use this for whatever we want to use in that case. So, without having to do any type of use